നമസ്കാരം. ഇൻ്റഗ്രൽ ട്രാൻസ്ഫോമിൻ്റെ ആദ്യത്തെ ക്ലാസ്സിലേക്ക് സ്വാഗതം. ഇൻ്റഗ്രൽ ട്രാൻസ്ഫോം എന്തുവാണെന്ന് ചോദിച്ചാൽ ഇറ്റ് ഈസ് എ മാത്തമെറ്റിക്കൽ ഓപ്പറേറ്റർ. നമുക്ക് ഓൾറെഡി പരിചയമുള്ള മാത്തമെറ്റിക്കൽ ഓപ്പറേറ്റേഴ്സാണ് അഡിഷൻ, സബ്ട്രാക്ഷൻ, മൾട്ടിപ്ലിക്കേഷൻ, സ്ക്വയർ റൂട്ട്, അങ്ങനെ ഡെറിവേറ്റീവ്സ്, ഇൻ്റഗ്രേഷൻ, ഇതെല്ലാം മാത്തമെറ്റിക്കൽ ഓപ്പറേറ്റേഴ്സാണ്. അതായത് ഒരു ഇൻപുട്ട് കൊടുത്താൽ അതിന് ഔട്ട്പുട്ട് ഈ മാത്തമെറ്റിക്കൽ ഓപ്പറേറ്റേഴ്സ് പ്രൊഡ്യൂസ് ചെയ്യും. അതുപോലെ ഇൻ്റഗ്രൽ ട്രാൻസ്ഫോമും ഒരു ഓപ്പറേറ്ററാണ്. ഈ ഇൻ്റഗ്രൽ ഓപ്പറേറ്റർ എങ്ങനെയാണ് വർക്ക് ചെയ്യുന്നതെന്ന് ചോദിച്ചാൽ അതൊരു ഇൻ്റഗ്രേഷൻ പ്രൊസീജിയറിലൂടെയാണ് വർക്ക് ചെയ്യുക. അങ്ങനെ ഇൻ്റഗ്രേഷൻ പ്രൊസീജിയറിലൂടെ വർക്ക് ചെയ്യാൻ ഇൻ്റഗ്രൽ ട്രാൻസ്ഫോമിനൊരു മറ്റൊരു ഫംഗ്ഷനും കൂടെ ആവശ്യമാണ്. ആ ഫംഗ്ഷൻ മിക്കവാറും ഫിക്സഡ് ആയിരിക്കും ഓരോ ടൈപ്പിനും. ആ ഫംഗ്ഷൻ മാറുന്നതിനനുസരിച്ച് ഓരോ ടൈപ്പ് ഇൻ്റഗ്രൽ ട്രാൻസ്ഫോംസും നമുക്ക് കിട്ടിക്കൊണ്ടേയിരിക്കും. ലാപ്ലേസ് ട്രാൻസ്ഫോം, ഫോറിയർ ട്രാൻസ്ഫോംസ്, സൈൻ ട്രാൻസ്ഫോംസ്, അങ്ങനെ പല പേരുകളിൽ ട്രാൻസ്ഫോം കിട്ടും ഈ ഫിക്സഡ് ഫംഗ്ഷൻ മാറിയാൽ. അപ്പോൾ ഇൻ്റഗ്രൽ ട്രാൻസ്ഫോം എന്താണെന്ന് ചോദിച്ചാൽ ഇറ്റ് ഈസ് എ മാത്തമെറ്റിക്കൽ ഓപ്പറേറ്റർ ദാറ്റ് പ്രൊഡ്യൂസ് എ ന്യൂ ഫംഗ്ഷൻ ബൈ ഇൻ്റഗ്രേറ്റിംഗ് എ പ്രോഡക്റ്റ് ഓഫ് ടു ഫങ്ഷൻസ്. അപ്പോൾ നമ്മൾ കൊടുക്കുന്ന ഇൻപുട്ട് f(t) ആണെന്ന് വിചാരിക്കുക. അപ്പോൾ നമുക്ക് കിട്ടുന്ന ഔട്ട്പുട്ട് g(s) ആയിരിക്കും. അപ്പോൾ ടി എന്നുള്ള വേരിയബിൾ സ്പേസിൽ നിന്ന് മാറി എസ് എന്നുള്ള വേരിയബിൾ സ്പേസിലേക്ക് നമ്മൾ മാറും ഇൻ്റഗ്രൽ ട്രാൻസ്ഫോം വഴി. അപ്പോൾ നമുക്ക് ഇൻ്റഗ്രൽ ട്രാൻസ്ഫോം കാണേണ്ട ഫോർമുല ഇങ്ങനെ പറയാം. ദി ഇൻ്റഗ്രൽ ട്രാൻസ്ഫോം ഓഫ് f(t) അതിനെ g(s) എന്ന് കാണിച്ചു. ഇൻ്റഗ്രൽ ട്രാൻസ്ഫോം ഓഫ് f ഈസ് g(s) which is defined as integral k of st f(t) dt, where the function k is called the kernel of the function. Here g is called integral transform of f(t) by the kernel k. അപ്പോൾ ഇതാണ് നമ്മൾ ഓർത്തു വയ്ക്കാൻ. g(s) is equal to integral k into f, where k is called the kernel and g is called the integral transform of f by g. ഈ ഇൻ്റഗ്രൽ ആക്ച്വലി -∞ to ∞ നമ്മൾ ഇൻ്റഗ്രേറ്റ് ചെയ്യാം. അപ്പോൾ അതിനെ ഡിനോട്ട് ചെയ്യുന്ന മറ്റൊരു സിമ്പലാണ് i of f(s), മീൻസ് ഇൻ്റഗ്രൽ ട്രാൻസ്ഫോം ഓഫ് f, which is calculated by the improper integral -∞ to ∞ k into f dt, where s is a parameter, may be real or complex, which is independent of t. Next we can see how the name integral transform to this procedure, because it transforms a function in one space to another space by a process of integration, which involves a fixed function which is called kernel. The kernel or kernel function is a function of variables in the two spaces and defines the integral transform. What is the application of integral transform? The integral transforms can be effectively used in finding solutions of linear differential equations, integral equations, also some probability theory it uses. Through the probability theory, integral transforms are derived. Several transforms are commonly named for the mathematicians who introduced them. അപ്പോൾ ഞാൻ നേരത്തെ പറഞ്ഞു, കേർണൽ മാറുന്നതിനനുസരിച്ച് ഈ കെയുടെ വാല്യൂ മാറുന്നതിനനുസരിച്ച് ഓരോ ടൈപ്പ് ഇൻ്റഗ്രൽ ട്രാൻസ്ഫോംസ് കിട്ടിക്കൊണ്ടേയിരിക്കും. നമുക്കതിൽ ആദ്യം പഠിക്കാനുള്ളത് ലാപ്ലേസ് ട്രാൻസ്ഫോം. Laplace transforms uses the kernel as e raised to minus st. That is, the kernel of Laplace transformation is e raised to minus st if t is greater than or equal to 0 and 0 if t less than 0. So we can introduce Laplace transform as L of f, the Laplace transform of f. Another notation is capital F of s, which is equal to integral 0 to infinity e raised to minus st ft dt. കേർണൽ ഇ റൈസ് ടു മൈനസ് എസ് ടി ആയ ഇൻ്റഗ്രൽ ട്രാൻസ്ഫോമിനെ വിളിക്കുന്ന പേരാണ് ലാപ്ലേസ് ട്രാൻസ്ഫോം. So if a function has Laplace transform as f of s, we can define its inverse also. That is denoted by L inverse of f. If f of s is the Laplace transform of f of t, small letter f of t, we can define f as the inverse Laplace transform. That is L inverse f, capital F is equal to f of t. Also, by the properties of operators, L inverse of L of f equal to f and L inverse of f equal to capital F. We can see some problems. Find the Laplace transform of e raised to at where t greater than or equal to 0. We have to find the Laplace transform of e raised to at, that is L of e raised to at, which is defined as integral 0 to infinity e raised to st into e raised to at, which is equal to e raised to st plus at dt. E raised to minus st, integral 0 to infinity e raised to minus st into e raised to at, which is equal to e raised to minus of s minus a dt. So the integral of e raised to minus s minus a t is e raised to minus s minus a into t divided by minus s minus a, which means a minus s, under the limit 0 to infinity. By applying the limit, first we put t equal to infinity, so e raised to minus infinity, which means 1 by e raised to infinity, which is equal to 0. And put t equal to 0, we got e raised to 0, e raised to 0 is 1. So 1 by minus of 1 by s minus a, which will gives 1 by s minus a. So we must remember the formulas. The Laplace transform of e raised to at is 1 by s minus a. E raised to at is transformed to 1 by s minus a through the kernel e raised to minus st, that is the Laplace transform. So the Laplace transform of e raised to at is 1 by s minus a. Similarly, the next problem is the Laplace transform of 1, the constant function 1. So we can find the Laplace transform using the formula integral 0 to infinity e raised to minus st into the given function. The given function is 1 into 1. By integration, e raised to minus st by minus s under the limit 0 to infinity. So e raised to minus infinity is 0 and e raised to 0 is 1. So answer is 1 by s. So through Laplace transform, 1 is transformed to 1 by s and e raised to at is transformed to 1 by s minus a. So we must remember some problems or formulas clearly. Also we can find the Laplace transform of sin at. Use the formula integral 0 to infinity e raised to minus st into sin at dt. By integration by parts, first function into integral of second minus second integral of derivative first into integral of the second. Apply ചെയ്യാം. Then again e raised to minus 80 into cos 80 വീണ്ടും integration by parts apply ചെയ്യാം. We got the answer as a by s square plus a square. Another method for finding the Laplace transform of sine and cosine functions are given in our textbooks. So we can go through it also. Derive the formulas. Laplace transform of cos omega t equal to s by s square plus omega square, and Laplace transform of sin omega t equal to omega by s square plus omega square. Here the numerator is s and here the numerator is omega. So here also we can apply integration by parts. Then we can get the Laplace transform of sin omega t here. So symbolize it as L of s, Ls. Similarly, for Ls, that is Laplace of sin omega t, applying integration by parts, we get one integral as Lc. So we got Lc equal to 1 by s minus omega by s into Ls, and Ls equal to omega by s into Lc. Substitute each other, that is put Ls in Lc. Here substitute the value omega by s into Lc here. Then we got as Lc equal to s by s square plus omega square. Here here is one term and here is another term. Put in on the same side and calculate it. Lc equal to s by s square plus omega square. Here also we got the answer. Another question is to find the Laplace transform of hyperbolic functions cos h at and sin h at. We know that cos h at equal to 1 by 2 into e raised to at plus e raised to minus at, and sin h at equal to 1 by 2 into e raised to at minus e raised to minus at. Applying the linear property of Laplace transform. Linear property means it is an important question in our university exam. State and prove the linearity property of Laplace transform. That is L of a ft plus b gt equal to a into L ft plus b into L gt. Proof is also done by applying the formula integral 0 to infinity e raised to minus st into a ft plus b gt dt. Using the properties of improper integrals, we can separate it as two integrals and take the constant terms outside. We got the result. So applying this result, linear property, we can write as 1 by 2 into the Laplace of e raised to at plus Laplace of e raised to minus at. We have done Laplace of e raised to at as 1 by s minus a. Similarly, e raised to minus at is 1 by s minus minus a, that is 1 by s plus a, which gives the answer s by s square minus a square. Also, we can find the Laplace of sin h at as 1 by 2 into Laplace of e raised to at minus Laplace of e raised to minus at, that is 1 by s minus a minus 1 by s plus a, which is equal to a by s square minus a square. Hence, the Laplace of hyperbolic sine at equal to a by a square minus a square, and cosine hyperbolic cosine is equal to s by a square minus a square. All of you should read this table and by heart and doing the problems also. That is, next problem is to find the Laplace of t square, hence the generalization of that power t raised to n. So t raised to n is also written in the gamma function, in terms of gamma function too. That is Laplace of t raised to n plus 1 by applying the formula integral 0 to infinity e raised to minus st into t raised to n plus 1 dt. Applying integration by parts, and we got this integral. We can write this integral in terms of gamma function. Also, we can identify this as the Laplace of t raised to n. We note that Laplace transform of t raised to n is n factorial by s raised to n plus 1. Hence, Laplace of t raised to n plus 1 is n plus 1 factorial by s raised to n plus 2. Using this result, we can prove the Laplace of t raised to n equal to n factorial by s raised to n. For that, we use the mathematical induction. First step is to prove the result for n equal to 1. For n equal to 1 means Laplace of t is equal to 1 by s. Laplace of t raised to n is n factorial by s raised to n plus 1. So, put n equal to 1, we have to prove Laplace of t equal to 1 factorial by s square. For that, we can apply the formula Laplace of t equal to integral 0 to infinity e raised to minus st into t dt. Applying integration by parts, we get first function into integral of the second minus integral of derivative first into integral of the second is 1 into 1. So here it will be 0, and this integral is again integrated, and we got the result 1 by s square. So the result for n equal to 1 is true. Now assume the result is true for n, that is Laplace of t raised to n equal to n factorial by s raised to n plus 1. Now we have to prove the result for n plus 1. That is, we have to find the Laplace transform of t raised to n plus 1. Applying the formula, we got integral 0 to infinity e raised to minus st into t raised to n plus 1 dt, and apply the integration by parts. We got the first term as 0 and second term as n plus 1 by s into Laplace of t raised to n. That we got the integral at that stage. We got the integral as integral 0 to infinity e raised to minus st t raised to n dt. That we call as Laplace of t raised to n. From the assumption, we got the Laplace of t raised to n is n factorial by s raised to n plus 1. So we got the answer as n plus 1 into n factorial, that is n plus 1 factorial by s raised to n plus 2. Hence, by mathematical induction, we got the proof of Laplace t raised to n equal to n factorial by s raised to n plus 1.